Oh my, look at this. We've got chaos. Woo. Okay. Okay. I guess I'm good to go. I'm recording and let's rock and roll. If this takes too long, then you can just give me some kind of signal like, hey, we get it, Mr. Ahern. So today is the 12th. And today we are going to add and subtract complex numbers. I learned a valuable lesson this morning that no matter how obviously easy something is or seems to be, you still got to do it justice. You gotta do the right thing. So today's cake, basically today comes down to combining like terms. Actually, you get all the way through today's lesson, and at no point do you even have to acknowledge that I is a number. By the time we're done with this lesson today, we just view I as a letter, and that'll change tomorrow. When we multiply, I becomes a big deal. But for today, we just kind of lug I around as if it were a variable like an X or a Y. So today really boils down to following directions and combining like terms. So let's begin with what it looks like when we add complex numbers. So here's a complex number like 4 minus 3i. And we're going to add to it a different complex number like, I don't know, how about 2 plus 10i? Got it? So a very professional explanation of this I'll give first, and that would be that in order to add things to other things, you need to get the things out in the open where there are no parentheses. But I want you to think about this, that if I get the parentheses off of this, you notice how there's nothing in front of the first parentheses. Therefore, when I pop the things out of the parentheses, nothing changes. Like that was fun. And then do you notice also how there's really nothing of any importance in front of the second set of parentheses? You could make a case that there's a plus sign. I get that. But a plus sign is like a positive 1. And when you distribute a positive 1, nothing changes. So the 2 is still just a plus 2, and the 10i is still just a plus 10i. If you're wondering, that seems really stupid. I don't think I should have to show that. I agree. I'm not going to ask you to ever show your work like I just did on an addition problem, because quite frankly, that would be silly. With addition, it's literally what you see is what you do. You take your real parts, you add them together. You take your imaginary parts, you add them together, and it's like, you're done. So even if I hadn't shown this work down here, I could just look at the problem from the beginning and say, hey, what's 4 plus 2? Well, that's 6. And then I could say, hey, what's negative 3i plus 10i? So I just put 6 plus 7i. I type that in, and yes, it is that easy. Now, that work that I crossed out up there with the big fat yellow pen, I'm not going to cross that out when we do minus. And it's like no one ever believes me until it happens. And then when we don't show our work on the minus, I'm not saying this applies to everybody. Some people will very purposely not show any work on the minus just to prove that they can, and they'll get them all right. More power to you. But for the most of us on this next problem with the minus, it's really, I think, important that we show work at least for a while until we go, I got this 100%. I can do this in my head. So here's what minus is going to look like. Does anyone want to pick a complex number? That's just can I have a real, an imaginary part too? Okay, so 12 plus 5i is what Diedrich meant to say. That's a great complex number. Good. And now I'm going to subtract from it another complex number. Anyone want to pick? Go ahead, Tom. Okay, great. So what we have here is an example of a complex number minus another complex number. And you can call me crazy if you want, but I do think that showing the work here matters. I had a young lady earlier today that for her, writing it down was literally the difference between getting them right and wrong. There's something to be said. So as I take the things out of parentheses, again, with the first set, we all agree that there's nothing here in front of the first set. So when we drop the 12 and the 5i out, they don't change. But years and years and years of watching kids mess this up has taught me that it's okay. It takes 5 seconds to show your work. And so what happens is that minus sign in front of these parentheses is going to go in and change that guy to a what? Yeah, plus 2i. Good. He changes. Everything changes. It's just a 2, excuse me. There's no stupid I on there. And then the negative also goes in and hits the 6i. And what does it change him into? Yes. And now if I understand that, then I never have to see the original problem again because the negative in front has done what he needs to do. Right? At this point, it's just a matter of combining like terms. You shouldn't obviously have any issues from here. What's my real part going to be? What's my imaginary part going to be? And I'm just going to put minus I. Does this make perfect sense? I totally understand if right now you're one of those people who thinks like, I'm going to see if I can do this whole assignment without showing any work. Like, I understand the challenge of that. And you may be successful with it and you may not. But if you find yourself missing any, because by the way, I did set this assignment to be a little bit more harsh. It's hard to explain why. I thought this would be one where I feel like you should really hold yourself accountable for perfection. Like, you shouldn't be missing this. And so what I set it as is number one, that's going to make it a little harder, is I didn't give you a second chance on each problem. So if you miss it, it's going to give you the red X right away. And it's the second thing I did is instead of your score going back 1, your score is going to go back 2. So if you start getting a little kooky with this, you might be like, oh, I'm all the way up to 18. And then you miss a couple and bam, you're back to 14, just like that. And so I really did that. It's kind of a jerk move, but at the same time, I did it because I really want you to hold yourself to that standard of, I can do this. So one more thing I want to show you so that I don't have to explain this 10 different times. Let's look at a problem like this. And I was unaware that this would be the case until my second hour students started doing their problems. And then I was like, oh, I probably should have realized that and said that. So I'm saying it to you. If we work this problem out, first off, it's a minus. So it's on my radar as one of those I should probably show my worky problems. So I'm going to copy the first ones out as -4 and -6i. What's my second batch going to be? And plus 6i, right? So when I look at my real part, I get -4 -3, and that's -7. And do you agree with me that the imaginary components cancel out? From what I understand, and I understand why because of the directions, Delta Math, if you put this in, is going to mark it wrong. And looking back, I realize it's because the directions explicitly state that your answer needs to be written in standard complex form, which is a plus bi. So what it's looking for is -7, as annoying as it is, plus 0i. And I believe it's the same if our real part had come out to be 0 as well. So like if you get an answer, let's say you get to the end of a problem and you're looking at like 4 -6i -4 -3i. As tempting as it is to just eliminate the 4s and have your answer be -9i, I believe it'll count that wrong. You need to have 0 -9i. And again, that's only just because of the directions say a plus bi. Everyone has to be there. Do you have any questions? All right, there's 30. I mean, you couldn't do as many as you want. If you keep missing them, you're gonna have to do like 50. But you have to get to a score of 30, and that's that. You gotta go? Yeah, sure.